Question 3a. So the patient with the body surface area of 1.82 meters squared needs to receive a drug at 10 milligram per meter squared rate. So first thing we need to identify is the want and the have. So the have is usually the easier one for us to identify because we have two quantities. We have a ratio, and even though that one doesn't look like a ratio, it's 10 milligrams per 1 meter squared, per each meter squared. So here are the two quantities that become part of our have in the box. That means this information here will be the want, the 1.86. So we start drawing our box and placing the elements that we know in. So first thing, the have, we use that 10 milligram per 1 meter squared. Then that's gone. We need to now enter the 1.86 meter squared that needs to match with the meter squared, so it should be sitting here on the bottom. So then our question mark will be sitting on the top. Before we do calculations using a calculator, we should do some quick estimate in our heads. So the relationship in the box is always horizontally or vertically, and this time I will look at the vertical relationship here, looking always at the numbers and the calculations that seem to be easy for performing in our heads. So 1 to 10, if the 1 changes into a 10, it means it was multiplied, because it got bigger, multiplied by 10. So it should happen to this number here as well. 1.86 must also be multiplied by 10. So 1.86 multiplied by 10 will have to be, instead of 1, 18. 18.6 is our answer. But let's see. So that is already in the background. We think that's the answer. There's not an estimate, but final answer. But we can also do the full equation. Looking at the main diagonal, we multiply those two numbers. So we get the 10 milligram multiplied by 1.686 meters squared, and then divide by the 1 meter squared. Even though you might say that 1 won't make a difference, we want to be able to do this to cross off the meter squareds and also to be consistent with other problems when we don't have a 1. This guarantees our answer is in milligrams, and then all we need to do is multiply 10 by 1.86 and divide by 1. So we got the same, 18.6 milligrams. So reading the problem again, how many milligrams are required? 18.6 milligrams. So let's move on to part B of this problem. So we have the answer in A, which was 18.6 milligrams. Now B says the drug comes as 0.15 grams per 20 mils. So how much is the patient going to need here in milliliters? So it's another one of those problems where we're going to draw our box and enter the have and the want. So the have is very clear here again, because we have two quantities separated by the per, the slash. So we could enter straight away 0.15 grams. Grams per 20 mils. So that information has been entered. We don't need to worry about that anymore. And then we have to enter the other information, the want. So this one here, milligrams, needs to match with milligrams. Oh, but now we see we don't have milligrams in the 0.15. So the first thing we need to do is actually change that. So 0.15 grams from grams to milligrams. We know we need to multiply by 1, 2, 3 zeros, multiply by 1,000, or move the decimal point 3 places to the right. So let's do that. 1, 2, 3. Room for a 0 here, so 150 milligrams. So what we can do is then, so not a crime to write it in as grams, so long as you know we have to change it to milligrams. So now the have is in, and we can add the 18.6 milligrams to the box. So now all we need to do is, well, first try to guess what the answer is by doing a quick estimate. 150, looking sidewise this time, goes down to 18.6. That's very difficult to work with in our heads, so we could make it a 15. So 150, if it went down to 15, that would be a division by 10. 150 divided by 10 would give us that. So we would need to do the same here. 20 divided by 10, which would give us 2. But we know it's not the answer, but it's an estimate, so a rough estimate, which is really important. But then we do write the whole equation and use the calculator. So main diagonal, multiply 20 mils by 18.6 milligrams and divide by the 150 milligrams. Very important to always keep using the units into the box, adding them into the box and also in the equation, because we can see clearly which answer we're going to get here. So the answer should be in mils. So we just need to perform the calculation now. And